Hey guys, welcome back to another lesson. Today we're going to be talking about, completing the square. All right, I'll do this in two parts, and then I'm going to upload an additional video, or maybe I'll include in part two. I don't know yet. Of the geometry, the geometric, I should say, interpretation of completing the square. Okay, this might be a review from Algebra 1. If it is, then hey, you get to have a chance to just refresh your mind just a little bit. Let's start with an equation that just has some rational roots first, okay? Let's take a look at an example. And what we're going to do is we're going to use a square root property to solve this guy. Not completing the square yet. That's coming towards the end of the video. Let's just talk about square roots for a second. Looking at this quadratic, typically what you would do is take 36, bring it over to the other side, and solve it. Okay, currently right now, you can solve it by either graphing, factoring. That's about it. That's the only two methods I've shown you. What else could we do? Well, notice on the left-hand side, this guy is a perfect square trinomial. What's that mean? Well, look at the first and last terms. They're perfect squares, right? What are factors of 9 that when I add them up, it gives me 6? And the answer is 3. Right? 3 plus 3 gives me 6. 3 times 3 gives me 9. I'm going to go ahead and factor this guy right here. Okay? So when I factor it, I get x plus 3 equals 36. Didn't change anything yet, by the way. This set of binomials is the same thing as this when I multiply them out. I'm going to condense this a little bit. Okay, since they're the same factor, each one of them, I can combine them as a square. Now, looking at this, I think we could solve it now, right? If I was going to solve for x, my first step is to get rid of this exponent. And I'm going to do that by taking the square root to both sides. The square root will cancel out the exponent. I'm left with x plus 3. On the other side, the square root of 36 is a positive or negative 6. In your geometry classes, you probably didn't really think about the negative side of square roots because we're talking about measurements. But now we're back in algebra, and we have to consider the negative part of a square root because that's a possible answer. Last step, subtract 3 to both sides. I get negative 3, positive negative, or plus or minus, I have to say, 6. Now from here, I actually have two equations. My first equation would be negative 3 plus 6. My second equation would be negative 3 minus 6. Okay? The first one will give me an answer of 3. The second one, when I'm done solving, will give me an answer of negative 9. So 3 and negative 9 are solutions to this guy up here. It's pretty cool, huh? Not a bad concept. So this is called the square root property. Okay? I want to rewrite this in some set notation. I'm going to try and bring it back just a little bit, almost like it was out of style. Set notation, that was like 80s, 70s. Now we're going to bring it back to the current trend for today. It's cool now, it's hip. So let's say that x equals 3, and then x would equal negative 9. So using set notation, we could write it in this format. It's still the same answer, right? What do you think? Not too bad, huh? Let's do one more, okay? And I'm going to put this right next to it. Here we go. Okay, so another example using the square root property. X squared minus 10x. Actually, you know what? No, let's do a different one. Let's do x squared minus 12x plus 36 equals 25. Okay? And tell you what, let me adjust some things here. There we go. I'm going to leave this on the side so you can use it as a reference anytime I'm solving this. Right here, I notice that it is a perfect square trinomial. What are factors of 36? And when I add them up, I get negative 12. It'd be negative 6 and negative 6. Okay? Therefore, I can factor this as x minus 6 equals 25. Now notice, when I'm starting these problems, I'm factoring right away. I'm not really worried about the 25 right now. I'm leaving it as is. I'm not bringing it over to the other side and working with it at all. Combine these. And if you notice, when we're done combining them, this looks like this guy over here. It's going to be the same process, right? Take the square root to both sides. That's going to cancel out the exponent. I get x minus 6 equals positive negative 5. Once again, don't forget that. I'm going to add 6 to the other side. And once again, I have two different types of answers that I could have from this. One solution is me adding 5. The other solution involves me subtracting 5. Just like that. My first answer can be 11. And my second answer is going to be a 1. There we go. Okay? There it is. So that's the square root property. Okay? Factoring it, getting to this point, and here's the deal. You can't combine these two unless they're the same binomial, right? Just like this. Go back to your original exponents. Okay, 5 cubed is the same thing as 5 times 5 times 5. It's the same base. I'm combining them together. If this is a 7, I can't combine them and take the square root. I think that's obvious, but disclaimer. Okay, that way you know. All right, now so that was like a simple approach. Let's go back a little bit. Let's say I have something that isn't a perfect square yet. I have to make it a perfect square. What does that look like? Let's take a look at another example. And I'll tell you what, let me make one statement here. That's pretty important. Okay. Every quadratic can be solved this way using the square root property. All right, it is possible. In some cases, it's probably not the best idea. Okay, when we're done with this entire chapter of quadratics, you're going to have enough tools under your belt to decide which method is the best suited to solving it. Okay, but we can get every quadratic to this point. We might have to manipulate it a little bit. For instance, look at this example. Okay, let's say this is my equation I'm trying to solve. And here's what I'm going to do. I'm going to add a number to this. Okay, and when I add this number, it's going to make this side a perfect square trinomial. I highly encourage you, let me just push this over to the side. There we go. I highly encourage you to pause the video and think about what number I can put into it. The number that's going to work is 64. Okay, 64 is going to make this guy a perfect square. How do I know that? Well, let's take a look. What are factors of 64? And when I add them up, I get 16. Only two that come to mind. That's 8 and 8. So it'd be x plus 8, x plus 8. That is what's going to work. Remember, perfect square trinomials have the same two binomials here. We're not done. We're almost there. But you see how the equation is kind of like out of balance? I add 64 to the one side, but what about the other side? Not quite there yet, huh? I have to make sure that I add 64 to the other side. That's very important to keep things in balance, okay? So on this side, we have everything factored. On the other side, when I combine those two together, I get 73. Now I'm back to my normal approach, right? I have x plus 8 squared equals 73. Square root both sides to get rid of the exponent. Now here's the deal. If I was going to graph this, I would make this a decimal. If this was a radical that I could reduce, I would try to reduce it. It's good practice, okay? But once again, if I'm going to graph it, yeah, I'd want to use a decimal. I'm going to subtract 8 to the other side. And I want to make this more of an exact answer. Because square root of 73 isn't going to come out pretty, instead of rounding everything, I'm going to leave it like this. And therefore, if I want to use this in a future calculation, I have all the digits, all the values right here. and I can use that to my advantage for wherever I do need it for. So I'm just going to leave it like this right now. Okay. Now, this isn't bad, right? Make this guy a perfect square trinomial, and go using the square root property. But can you see how we figured this out? How did I know this was going to be a 64? I mean, you can guess and check. It was this guy, right? The b term. If I take half of this b term and I square it, don't I get 64? And doesn't half the b term give me the factors? Aha! So let's make a note right here. If we take half the b term and square it, we have the value that will make a polynomial a perfect square polynomial. A lot to write, but I like to put some English behind it. Okay? So if I took half of this guy and squared it, I was able to get my perfect square trinomial. That's pretty handy, isn't it? Like for instance, let's try another one, just off the spur of the moment. How about x squared plus, let's try 14x. What number would I put into here that would make it a perfect square trinomial? Time's up. It's going to be 7. Factors of this guy, take half of it, right, which would be a factor, which would be 7. And if I square it, I get 49. So 49 is going to make that a perfect square. And it's going to be what? X plus 7, x plus 7. Okay? It's kind of cool that we have the ability to do that. Huh? All right, now, what we did here, we're now going to use to do what's called completing the square. Okay? So, ready to get started? Are you? I don't think you're ready. You don't sound ready. Let's just put it that way. You're always quiet. Come on. Be happy? No? Okay, fine. I'll just go ahead and write the problem down. All right, we have x squared plus 10x minus 11 equals 0. Now, can we, yeah, that's good. All right, let me just erase that. I want to keep this in frame. I'm going to use this as a reference. All right, now there are so many, wish I could cut that out of the video. There are 2 ways of doing this, okay? 3 if you count the geometric way, which we'll discuss another time. What I'm going to show you is I'm going to leave the negative 11 on this side of the equation, okay? Instead, what I'm going to do is I'm going to group the first 2 terms together, and that negative 11 is going to be outside the parentheses, okay? And just like over here, I want to find a number that makes this guy a perfect square trinomial. Now, you probably would guess by now that it's half this guy, right? And we square it. So if it's 10x, it becomes 5x, or just the coefficient, 5. And if I square it, I get 25. That's what I'm going to put into there. Now, I'm going to write this as a separate step so it's easier to follow. So here we go. X squared plus 10x plus 25. I have an issue, though. It's great that we made this a perfect square. Not legal. It's not math legal. Probably thinking, what do you mean, Mr. McCall? What do you mean it's not math legal? I added 25. That changed what this was, right? It's no longer the original equation. If I combine these together, do I get this guy? No, I don't. So what I'm going to have to do is subtract a 25 on the outside to keep it balanced. If I were to combine, now the parentheses are just there for grouping, okay? If the parentheses were gone, see how the 25s would cancel? And then what do I get? My original, okay? I don't want to change the integrity of the original equation, so I'm going to have to subtract that out, okay? Factor this guy that's in parentheses. it'd be what? X plus 5 squared. Now notice, I am skipping one step. I'm not writing it out twice. Are we okay with that? Yeah, we're good? All right, awesome. You guys are awesome. And then on the outside, we get minus 36 equals 0. This guy right here, I'm going to put a box around it, is the same thing as this guy up here. They're identical. This one's written a little bit differently, but they're the same. If I were to expand this, I get this guy, right? Negative 36 is this guy. If I combine these together, I get the original. So hopefully you can make that connection where I didn't change nothing. It's okay. Now let's solve this. Add 36 to the other side. And then we're back to what? Square root property, which is what we've seen over there. Take the square root to both sides. X plus 5 equals plus or minus 6. Subtract 5. We get negative 5 plus or minus 6. Now here's the deal. We have two answers here. It's a quadratic. A quadratic can have at most two solutions, real solutions. It can have one real solution or, well, what did we do the last lesson? Complex, right? It can have two imaginary solutions, okay? So for this guy, if I add these together, I get a 1. If I subtract them, I get negative 11. There's my two answers. So both of these guys would satisfy the equation. That's completing the square. See how it kind of takes from what we did previously? So we started the lesson with this, right? Then we did an example like this, and then we kind of put it all together. All right? Pretty cool, huh? Now, I know what some of you are thinking. I could have just factored that easily. I probably could have just, put 1. X plus 11, x minus 1 would be factors for that. Finish it. Yeah, you'd be right. All right? And that's fine. This is just showing you another method to actually solve it. So there's other ways of solving it that could be quicker. It may be easier. But I'm just showing you how completing the square works and how it can be used. Got one more example. Can you hang in there? Just one more, please. And that's it for part 1. I'm going to leave this guy up as a reference. We have x squared minus 10x plus 24 equals 0. Now notice, see how both equations were set equal to 0? You want to make sure you have that, okay? The previous examples, I didn't do that because, well, this was already a perfect square. I didn't have to worry about that stuff. So in here, you want to set it equal to 0. It's a lot easier to start that way. What I'm going to do is group. Just like that. I want to put a value in here that makes this guy a perfect square. And I think that's going to be 25. Right? Remember, it's half your b value, and if I square it, that's going to make this guy a perfect square trinomial. We're not done yet, though. Remember? Do you remember? You better remember. What's wrong with this? Come on, tell me. Subtract 25. That's right. You got to subtract 25. This currently is not the same equation as this guy. So I'm going to subtract 25. Therefore, these 25s cancel out. I get the original. Now I'm going to factor what's here in the parentheses. That's going to be what? X minus 5 squared. On the outside, we get what? Minus 1 equals 0. Now we're back to this guy. All right? I don't know about you, but it's kind of feeling a little redundant. But that's not a bad thing. If it's feeling redundant, then that means you're at least understanding it. And it's not feeling as new as before. Add 1 to the other side. Okay. Take the square root to both sides. x minus 5 equals plus or minus 1. Square root of 1 is just 1. I don't have to worry about it. Add 5 to the other side. We get this guy as the following. Okay, 2 answers. If I add them together, I get 6. If I subtract them, I get 4. There's my 2 final answers. You could write that in set notation. That's no big deal. Okay? We could just leave it like that. Either way. Could you get to these answers just by factoring normally? Absolutely. It's fine. So if you're looking at me like, wow, Mr. McCullough, can I just say that it's just x minus 6x minus 4, and then set each one equal to 0 using the zero product property? You could. You easily could. But I'm just showing you that you could do this using like a perfect square trinomial square root property, meshing them all together, and call that process complete the square. Okay? To me, the algebra makes sense. It works with me. But I'm still going to try and show you a geometric viewpoint as to why this works. Okay? So stay tuned for that. The video will come out soon. But this is it for part 1. Okay? Part 2, I'll upload later on. And it's going to be what happens when the a value has a number in front. It's no longer 1, it's bigger than 1. So what do we do about that? Or even if it's not bigger than 1, if it's just a fraction or something, like how do I work with that? How do I still make this a perfect square trinomial? Okay, and that's what we're going to cover tomorrow. But until then, guys, I hope you have a good day. I'll see you in the next lesson video.